Hi everyone, my name is Sai Vennam and I'm with the IBM Cloud team. Today we want to talk about operators. And no, I'm not actually talking about operations teams, but instead the operators framework which can be used on Kubernetes or OpenShift. CoreOS actually introduced the operator framework back in 2016. CoreOS is now a part of Red Hat and IBM. Operator framework is quickly picking up traction as it's a great way of managing complex Kubernetes applications. Now, before I jump into this, we want to actually introduce what the Kubernetes control loop is, because that's a core part of the operators framework. In this video, we're going to be talking about things like deployments and pods. So if you're not familiar with those, be sure to check out the Kubernetes Explained video that I've done on those topics. But let's get started with exactly what the control loop is in Kubernetes. Now, essentially, the way it starts, the control loop, it's a core part of Kubernetes. It observes the state of what's in your actual cluster. So that's the first step, observe. Next, what it's going to do, Kubernetes, is going to double check that the state in the actual cluster versus the state that you want it to be. So it's going to do a diff. And finally, it wants to resolve that diff by acting on it. So the last phase of the control loop is act. Now the control loop is core to how Kubernetes works, and there's a controller that basically acts on that for every default resource. Kubernetes comes with a number of default resources. Let's see an example of deploying an application without operators using these default resources. So as an end user, essentially, the first thing you're going to want to do is write up some YAML, right? The spec for that actual application. And for our particular example, let's say that we're doing a deployment. And in this deployment, we'll have to define some configuration, things like what's the image, and maybe the replicas, and maybe some other configuration. So that's one Kubernetes resource. And essentially, what you would do is take that and deploy it into your Kubernetes cluster, at which point a deployment is made. Here's where the control loop kicks in. So Kubernetes observes the state of your cluster. So we've got our Kubernetes cluster here, and checks what's the difference between what you want versus what's there. First thing it notices, there's no pods. So it's going to act on that difference, and it's going to create some pods. Now, let's say for a fairly complex application, we don't just have one YAML, but we have a second YAML. Maybe it's for the back end. And so that deploys a second deployment. And that, in turn, deploys a pod using the controllers and the control loop. Now, it's a simple example, but say you want to go through here, scale up the application, make some changes, set up some secrets, environment variables. Every single time, you have to either create new Kubernetes resources or go in here and edit the existing ones. That can start to get fairly difficult. Now, let's see how that's done in a world where we're using operators. Now, the first thing you would actually need to do is install the operator itself. So someone in your team has to create the operator, or maybe you can use one of the many that are out there on Operator Hub, where the community is building on the operators that are available. So the first thing you need in your Kubernetes cluster is the OLM, which is the Operator Lifecycle Manager, which basically manages the operators that you have installed. Next, you deploy your actual operator into the cluster. The operator is made up of two major components. The first component in an operator is going to be the CRD. The other one is going to be the controller. Now, the CRD is basically a custom resource definition. So we've talked about default resources, things like deployments and pods. A custom resource is something that you define as a user in Kubernetes, or maybe an operator defines it, so that you can create YAML to work against that custom config. The controller is basically a custom control loop which runs as a pod in your cluster and runs this control loop against your custom resource definition. So let's say that an operator is created for our custom application deployment here. So instead of having to write multiple deployments and setting up config maps and secrets for whatever our cluster needs, we instead, as an end user here, will instead actually just deploy one YAML maybe we called this operator my app. We could be a little bit more meaningful here. We could call it stateful app, front-end app, whatever we want it to be. And then we could define some config here, or we can use the defaults that are set. You kind of have a choice of options here. Then we take this operator and we deploy it directly into the cluster. At this point, the operator takes over, and this is actually responsible for running that control loop and figuring out exactly what needs to be running. So it's going to realize that we need a couple of deployments and the pods. Now, this is a kind of a format or approach to managing applications that's inherently easier and scales better than this approach. Because as an end user, you really only have to worry about the config that's been exposed to you, and the operator itself manages the control loop and the state of the application, how it needs to look. Now, there's great operators out there already, things like managing etcd or various databases, or even IBM Cloud services. So all of those operators currently exist on Operator Hub. But say you want to develop your own, maybe a custom operator for something that is native to your application architecture, kind of like what we sketched out here. Well, there's a number of ways you can do that. And there's something called the Operator SDK that allows you to start building out operators yourself. Now, I'd say the easiest way to get started with an operator is to use the Helm one. So Helm, as you may already know, there is a video where David Okun goes over exactly how Helm works. Be sure to check that one out. But the Helm approach allows you to take a Helm chart and apply that towards an operator, expose config, so it allows you to get to a fairly mature level of an operator, kind of something like this for a chart that's already there. Now, the maturity of operators, what I've sketched out down here, falls into 5 different levels. Now, Helm actually hits the first 2 levels of maturity. Let's talk about what those levels are. The first one is basic install. Essentially, the first level is basically going to allow you to do just provisioning of the resources required. Now, the second phase goes a little bit further. It's going to allow you to do upgrades. So this supports minor and patch version upgrades to whatever is defined in your operator. Now, Helm gets you that far. What about for the next 3 levels of maturity? For these, you're going to want to use either Go, or you can also use Ansible. Now, these will allow you to actually get to all 5 levels of maturity with operators. Let's quickly talk about what those are. At the 3rd level, we've got full lifecycle support. So this is storage lifecycle, app lifecycle. It's also going to allow you to do things like backup and failure recovery. So that's something that would be kind of configured and developed into the operator, whoever developed that one. 4th, what we've got here is insights. This is going to allow you to get deep metrics and analysis, logging, that kind of thing from your actual operator. And finally, what we have is something called autopilot. And just kind of how it sounds, this is going to have a lot more functionality built into the operator itself. Basically, it's going to allow you to do automatic scaling, horizontal and vertically. It's going to do automatic config tuning. If your operator-based app gets into a bad state, it's going to identify that automatically. So these are kind of the 5 levels of maturity that operators can have. By looking on Operator Hub, you can see the ones that the community has developed and see what level of maturity that they hit. And then again, by using the Operator SDK, you can build your own operators using either Helm, Go, or Ansible. Thanks for joining me for this video on operators. If you have any questions, be sure to drop us a line below. If you want to see more videos like this in the future, please like and subscribe. And don't forget, you can always get started on the cloud at no cost by signing up for a free IBM Cloud account.